Okay, this is our video for 5.1. This section is all about perpendicular bisectors and angle bisectors. So remember what we know about perpendicular. We know perpendicular means that they meet at a right angle, and later on we'll talk about perpendicular also means that their slopes are opposite reciprocals. Bisector means to cut in half. So a perpendicular bisector is a segment that both cuts another segment in half and is perpendicular to the original statement. So you have your perpendicular bisector theorem from your vocabulary grid. Make sure you flip over and look at that. It says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So this is what we're talking about right here. I'll just explain it with this example. You can tell that NP is a perpendicular bisector of ML. Perpendicular because you see the right angle, bisector because you see the tick marks right here, so it's cutting ML in half. So what our new theorem says, the perpendicular bisector theorem, says, okay, if this is on the perpendicular bisector, then NL is congruent to NM. So if these two are congruent because it's bisected, then these two are congruent as well. So what that tells me is MN is equal to 2.6 by the perpendicular bisector theorem. Okay, so you're looking for this setup right here, perpendicular and bisector. Okay, so here it is for B. It is the same, no, this is the converse. So this looks like the converse because I see that it's perpendicular. That has to be there no matter what. But instead of me noticing that BC has been bisected, I don't know that yet. But what I can see is AB is congruent to AC. So this is the converse. In the original, we see that the segment we're talking about with the perpendicular, that has been bisected, so the other sides are congruent. Now we're going backwards. We're saying, okay, it's perpendicular. The outsides are congruent, so this must have been a perpendicular bisector, meaning BD also has to be 12. So if BD is 12 and DC is 12, then BC has to be 24. Make sure you're answering the question that they ask you, not just finding what you think and going with it. Okay, so this is the converse, this is the original. Make sure you recognize that. Okay, pause here and try C with a little bit of algebra. Okay, so C is the perpendicular bisector theorem because I have perpendicular and I have bisector. So that means I know that these two sides are congruent. So here's 3x plus 9 is equal to 7x minus 17. Now this is where we stopped earlier, but now we just have to solve. So x is equal to 6.5. Now it's asking me to find TU, so I'm going to go and plug that back in here. 3 times 6.5 plus 9, that's 28.5. Okay. All right, let's switch over to angle bisectors. Same concept, only instead of being bisecting the side that it's across from over here, now we're going to be concerned if it bisects this angle over here. So you still have the same converse and regular. Okay, based on these theorems, an angle bisector can be defined as the locus of all points in the interior of an angle that are equidistant from the sides. So let's flip over to an example with a picture of an angle bisector and I'll tell you what that means. Okay, let me square back up here. Alright, so here we can tell that this is an angle bisector because I can see that these two little angles in the middle, BAC and CAD, have been bisected. What it means by the locus of all points is this point is on the angle bisector because it's equidistant here. This point is on the bisector because this angle is congruent here. This point is on the bisector and on all the way out. So locus just means any point that satisfies the given condition, and in our case the condition is that it needs to be the same angle on both sides. So anywhere along this angle bisecting line will work for that. So that's all this says. Now notice in your theorem it says it's equidistant from the sides, so I'm going to go from any point on this angle bisector, I'm going to go straight out to the sides, and that would be congruent. Any point here straight out would be congruent. How we know we're going directly there and not like at a weird angle over here is you can see these right angle marks in here. So that's the reason those right angle marks are showing. It's not a perpendicular bisector like we just talked about. It's just saying, hey, I went from this angle bisector and I went straight to the edge. I went from the angle bisector, I went straight from the edge. I didn't veer off in any direction. So what this says is when we have the angle bisector, these points are going to be equidistant because the angle bisector is directly in the middle. So when I go to each side, I'm going the same distance away each time. So if this is 7.2, then this has to be 7.2 as well. So this is the angle bisector theorem. So now I drew all over my picture, but you can tell. So you're going to look, when you look for an angle bisector, you're going to look that the angle in the middle has been bisected. Then from there, any point, if you go directly off to the side, that will always be equal. As you move down the angle, it'll obviously get bigger and bigger and bigger, but this side will still be congruent to this side because this angle is cut in half all the way down the middle. Okay, so let's look at B. This is the converse because I don't see those little angle markings there, so I'm not sure if this is congruent yet. But what I can see is from a point on this line directly to the outside, I know I went there directly because I have those right angle marks, is congruent. So that means FH must be in the middle, so this must be an angle bisector. So this is the converse because we went backwards. Okay, I know I went backwards because I didn't have the angle marks to start with. I had the side links, so I went backwards to find the angle. Okay, so what that says is if EFG is 50, the whole thing is 50, then when I cut it in half, each of these little pieces is 25. So the measure of angle EFH is 25 degrees if the whole angle is 50. Okay, y'all pause here and try C with a little bit of algebra in it. Okay, this one's a converse as well because you can see I don't have the angle marks yet, but I do have the tick marks on the inside telling me that M is in the middle, so it must be a bisector. So I'm going to go ahead and set 3A plus 20 equal to 2A plus 26. Solve that out to get A is equal to 6, and then plug it back in for MKL. So I'm going to plug it back in here, 2 times 6 plus 26. So that angle is 38. Hopefully you got that right. Okay, let's do a little bit of a word problem here. Alright, John wants to hang a spotlight along the back of a display case. Wires AD and CD are the same length, and A and C are equidistant from B. How do the wires keep the spotlight centered? Okay, there's several ways to go about this. This is kind of a combination of perpendicular bisector theorem, and you could also use angle bisector if you wanted to. So what we know is we know B is the midpoint of AC because it said these are equidistant from each side length. And if these sides are congruent over here, then what must have happened is BD must be the perpendicular bisector. Now you can use the perpendicular bisector theorem to prove that, but this isn't the exact setup that we've had because on both the converse and the regular we already knew it was perpendicular, and in this case we don't. So one way that's really easy to look at this since we just studied this is to look at the two triangles. Maybe get a different color. The two triangles on each side. I know this side's congruent to this side. I know this side's congruent to this side. I know BD is congruent to itself by reflexive. So I know this triangle over here is congruent to this one over here by side, side, side. Side, side, side. So that was in last chapter, but none of that stuff goes away. So if these two triangles are congruent, then I can get all the information I need. These angles are congruent, meaning BD is an angle bisector. Also, these angles are congruent, and since they form a straight line and they're congruent, they have to be perpendicular. So long way around it, or you could shortcut with the perpendicular bisector theorem, but either way, what you come to find out is that BD is the perpendicular bisector of AC. Okay, perpendicular because I know these angles have to be congruent and they form a line, so they have to be 90 degrees. And bisector because they already told me that AC is A and C are equidistant from B, so B is the midpoint. So since BD is the bisector of AC, that means that this spotlight is going to hang exactly balanced because it's on the perpendicular bisector. Okay, now this last one is your algebra approach here. Write an equation in point-slope form for the perpendicular bisector of the segment with endpoints 6, -5, and 10, 1. This is an example you want to hold on to very closely because this is really important. You're going to do this now. You're also going to do this again in pre-cal, and so she's going to expect that you know how to do this, and so will I. So, two things going on here. I want it to be perpendicular. And we talked about at the very beginning that perpendicular means it's going to have an opposite reciprocal slope. And I want it to be a bisector, and we've talked about several times this year that bisector means it's going to go through the midpoint. So two things I'm looking for: an opposite reciprocal slope going through the midpoint. So first let's start by finding the midpoint, and we've done this several times this year. Remember, that just means to find the average of the 2 points. So we're just going to add them up and divide by 2 so I can find out where the middle is. So when I find the midpoint, I add them up to get 16, -4, divide them by 2 to find the middle, and I get 8, -2. So I can tell that the midpoint here is at 8, -2. Okay? Now what I want to do is I want to find the slope of my original line so that then I can find the opposite reciprocal slope. So remember, slope is rise over run. So from -5 to 1, I rose up 6 places, and from 6 to 10, I ran over 4 places, so that means my slope is 3/2. Now keep it in a fraction because that's actually going to help you in a second. So my slope of this original line is 3/2, but I want to be perpendicular. So remember, perpendicular means opposite reciprocal. So opposite meaning this was positive, so I want my slope to be negative. And reciprocal means flip it over. So this was 3/2, so I want mine to be 2/3. So now I just have to get to the answer part. I need to write an equation in point-slope form. This is point-slope form. I have a point because it's going to go through the midpoint, and I have my new slope like this. So I just need to put these together in point-slope. Y minus y1 equals m times x minus x1. Remember, the minus sign comes from the formula, so when I have another negative, it's just going to serve to change that to positive. Now I'm lucky today because it said, hey, leave it in point slope form, so this is my answer. Y plus 2 equals -2/3 x minus 8. If it said to write it in slope intercept form, I would do the exact same process, except for from here I would go ahead and distribute and solve it out. But since it said point slope form, here I am, I'm done. Now this is your important example today, so you might want to go back and rewatch that or write one from the book.